Shall I get the whiteboard? Yeah, get the whiteboard. Get the whiteboard. And grab the whiteboard. Oh, gosh. Oh, okay. Oh, relax. It's going to work. Yeah, probably will. Okay. Okay. Try and draw a smooth curve. Well, that's not quite smooth. That kind of went a little bit the other way. Got to do this with shapes, haven't you? Chunk it up a bit more. Something like that. Okay. See that? Oh yeah, I can see that. So, actually, you couldn't have it. Can always change it. It's not like I'm using a sine wave. That'll be smoother. I'm not sure how much difference because unless I went into an auditorium and measured it myself, from the front, going back several feet each time, and taking the measurements every several feet, stepping back. I've always, auditoriums typically have a slope. One, for line sight to the be whether it what the difference between concert halls and cinema auditoriums. I mean, concert halls would have a little slight variance in the floor, in the lower area. The floor sloping, so it goes from the front and it slopes upward, going toward the back. and where exit doors are located, or entrance doors are located, versus a home, which is um, or versus say a typical auditorium, multiplex auditoriums, so say classic auditoriums. Um, some of the multiplex auditoriums, some of them today, the design where they have a entrance, main entrance that goes in one way, and then the floor is sloping up, because how everything is designed and raised slightly inside the room, and then you got this dividing wall going down one side, which kind of, I don't know if that sucks or if it's a base issue. And then you go and look round, and then you could see the seating going upward, and getting nearer to the back. The floor to ceiling height is getting less, so it's not as great as the front, where it is great at the front due to where the speakers would be located behind the screen. So actually, there's a waveform going that way. Studio. I would say there's another one going that way. And yeah, and it's complicated, because the bass wave from the stage channel is going to go down to the floor, the down to the floor, up to the ceiling. The speaker's height position should be around about equal middle position, because if it were too close to the floor, it's going to get a different bass wave where it starts off at, and vice versa if it was near to the ceiling. Depending on which way the angle is facing, I suppose. So typically a home, home is just an oblong or not a rectangular room or square, or, well, maybe something different, but it's always where a system goes into a room. Bass is going to boom at some point at the front at its highest level first, and then as it gradually that bass wave signal as it goes, depending on if it's the same bass note, but it's better to test it with sine wave tone or pink noise. Sine wave tone, you could, and set up a few microphones, and so you can see kind of roughly the waveform shape on the oscilloscope, or look at the observation of it on the RTA analyzer. It's very easy just to look at say, like, play 20 hertz. What does the sine wave look like? It generally doesn't change too much, just tiny fractions. Then you go up to other frequencies, and then they start to drastically change even if you walk through the room and just listen to the tone, you can just hear the pressure kind of like played at a comfortable level. So it doesn't really matter, because the shape of the room is going to emphasize, it's going to add on some extra boost level to that frequency. Um, the thing is, yeah, a floor needs to slope. I can't realistically put a sloping floor in the room. That's gonna be literally, so when it gets to the back, it's got the same height, it's got the same thickness. So I can't have like a little part of the entrance way where I go in through the door and I step. Otherwise, the rest of the thickness of the room of the to minimize the bass boom, it would be pointless because you don't see classic cinema auditoriums designed that way. Um, Unlike some of these newer multiplexes, which I think may be a little bit technically flawed. But you got to build a raising, sloping floor, so it's gradually at a certain point in the room it starts to slope and go upward. But our rooms are not the size of cinema auditorium. Well, they're not great size rooms. Typically we you got a hot ceiling height, average just under 8 foot. For typical most homes is just about under 8 feet. Some homes, depending on how what they're designed, they might have an uncommon average of maybe 9 or 10, maybe 12 foot. It depends. I've lived in a home, well, my parents' home, it was years ago, and then I was even thinking, well, it'd be nice to convert this room, this lounge, into a home cinema room, but add a nice ceiling height. Um, I think it was about, 12 foot. I think it was about 12 foot. And you think you got a ceiling that high? There's not much you do in a room because typically, well, unless you're a very tall person, you walk into a room, and then you kind of crouching down because the ceiling height, you kind of feel like Alice in Wonderland drinking the potion, and everything starts shrinking or such, and you got to go through the rabbit hole. How deep down does it go? Yeah. If cinemas didn't have this sloping floor sort of thing, and it was just the way it just typically is, just a room, with seating just placed in it, you'd have people standing up and trying to look, to see the screen, as well as there's other things as well, such as high frequency directivity. So you localize the sound positions, even though the further you go back, the stereo width is just getting narrower. That's just the way things are, even in the real world with real sound. That's just the way things are. You can't change it that much unless you do certain things with certain proper materials, and you could probably make the sound from across the road to someone else on the opposite side maybe sound a little bit, without really the aid of using PA amplified system. and you just find other properties, other materials to just kind of magnify the sound. Um, well, um, mm, I don't know about bass waveforming. I see the Trinov room, the Trinov home theatre, home cinema room, and it's from what I can see. I can't see the whole room because they haven't shown or moved the camera around the whole room. But from the look of it, it's got a very steep, not very steep. How many rows seat? I think one, two, three. I think they got 3 or 4 rows of seating, and so the floor is sloping up pretty thick, I would say. But I don't know where their entrance door is. If they got an emergency exit at the back of the room, or the entrance door is at the front of the room. Um, I don't know. Um, but I think looking at the room, I think why would they want bass waveform? I mean, surely they're not going to get any of that booming sound, you know. Um, I can't remember my room entirely. I know if I play 30 hertz, it does boom at the back of the room. It is um, a little bit too much, um, you know, and the boom is going to get a little bit less if I go just one row forward slightly in the seating area. If I stand toward the back of the room, I can still hear the boom slightly. Um, if I open and close the door, sort of thing, it's going to minimize by a little amount. I'll probably maybe do another update to this video, maybe a live video, because I haven't been in the room for, what's it now, 2 days, I think. Might be 3 days, I can't remember. I think it's 2 or 3 days I haven't been in the room. So um, it always bothers me, and if you cut EQ and such at certain frequencies, um, it doesn't really help that much, because really you're cutting the frequency energy on the speaker. Or actually the speaker. The amplifier is really irrelevant, because the amplifier is just there to provide dynamic range, and as long as you got enough power on the amplifier, you haven't got a tiddly 10-watt amplifier. Otherwise, you would definitely run out of headroom. You'll be clipping it a lot, I would imagine, because you'll be asking too much for it, and you'll just damage it. You know, I'm talking about these little tiny little circuit, small amplifiers that you buy in these little kits. You know, that require they don't have great current transformers on them. You know what I mean? Anyway, the way to do it is just, you got to look at a typical home theater basement is going to be about more or less the same height as my room. No more than greater than 8 feet. And unless you look at the room and think, well, how many seating rows you can actually put in the room, and you got to make it literally right to the back of the room, so it's the floor is going up and it's very thick. It can't be flimsy, right? It's got to be very thick and robust. And then that should, when you take your measurements, you take them before you do you do measurements all the way through the room, every several feet, so you know where the microphone's going to be placed, etc., the positions. When you redo when you redo it, once you built it all in and put the microphones more or less in they won't be in the exact same position because the floor will be sloping slightly. It'll be, like here. You see the wave, and they have the floor sloping up. And so when you get to the back, it's not going to boom. It'll have energy in the front. And like I say, the speakers, ideally they should be halfway positioned so that the bass even though the bass wavelength is going to be still bigger than the room, but the speaker will be equal positioned between floor and ceiling. And so the bass energy goes out into the room, but the wave, it shouldn't have this boomy, because I don't notice that when I go into cinemas. I don't notice it booming. It's loud, yes, but not booming. Not boom, boom, and this thing, bloody hell, what's this annoying bloody frequency, crying out loud? No, the auditorium's designed. You look back decades and decades. They got this slope. I'm not sure about balconies in auditoriums. I've only been in a few cinemas where they've got balconies, but it's difficult to sort of like listen to a soundtrack on a film. You got to have a scientific test with either peak noise or sine wave tones. That's what I believe. I believe the trick there is the floor and the thickness of it and where the door entrance is going to be. It won't work in my room because if I put something like that in, I still have to walk in the room and then step up onto something to get onto the back part of the and the ceiling is only 7 foot 8 inches. 7 foot 8 inches, and I have to take into account, say, average person height, maybe just about 6 foot or less, and then walking into a room, and then when standing on the back row, when standing up, you're not going to bump your head on the ceiling, sort of thing. There's still going to be some clearance. But problem there being is what I just mentioned, this thing where you walk in and you have to step up, and that area over to one side of the room is going to be right down to the floor, right up to the ceiling, and it's probably going to boom. It's probably going to have that boom issue. And maybe when moving slightly over to one side into the seating area, the boom may suddenly may decrease because you're standing in an area where, I suppose it's the same way with, I don't know, maybe temperature. When it was heat wave in the room, I had the air vent extractor thing from the air conditioner going out, well, near to the window. The window was only open a little bit, so the heat would go through it. But sometimes my cat would go behind it and move it, and then the heat is then blasting out of it against the window, and then it's flowing around in the room. And if I walk into us, so it's cooler over one area where the air is coming out cool, and I walk over to the other side and I can feel the heat. And I think, I've got to reposition it so it's pointing toward, and the airflow is going out. The heat airflow is going out through the window gap. So I suppose that's a similar principle. It's like the bass is too warm in it's okay at the front because it seems natural, maybe. I suppose it would be the same if I take an SBL meter or maybe an SBL meter, because typically the hum sound, because I could record it on a phone and then I could play that back on the I could play that back using the Spectrum Lab, and I'll be able to see the wavelength or the frequency, or maybe use the RTA analyzer, and I'll still be able to see where the peak of the frequency is. Because once the bus goes into motion, that bass boo, which is kind of going like this, it's pretty loud. Not uncomfortable. That I've noticed recent. I have noticed a bus where one time it wasn't typical sort of idling humming sound. It was really great and really resonating a lot. Everything was just completely rattling and vibrating on the bus. It was very uncomfortable. But typically, the lower deck on a bus, or even a single bus, I suppose when walking from the front and then gradually walking towards the back, that's where the engine will be located at, does that bass tone, which is about 35, 36 hertz, typical on a bus, does that change much? I mean, the height of the bus is the same. There are little areas on the bus where it does sort of step up a little bit. So, and then you step down and the ceiling height is just a little different. There's the length of the bus, the width of the bus. What's that got to do with home cinema? It's got a lot to do, because it's still acoustics. And then it's controlling the bass, I mean, would doing something like this be cheaper than buying a Trinov? So you have the use of the software of waveforming. Because I look at a lot of home theatre rooms, even some of these ones where they say, "Oh yeah, I'm an acoustic technician," or blah blah blah, and there's not much difference in the seat rising. And then I look over to the sides of the room and I can see where it's just going a flat floor. And it's just it's just like my room. So, my seat riser is only, at the back, I think it's only about 6, about 4, about 4, 5, 8. I think it's about 12 inches, 1 foot. That's not a great deal, but it's still a little. But I'll probably do a video where I'll set up a couple of microphones and then take a measurement at the front, and then move the microphone to the middle and then to the back, and just observe just how much difference there is between certain frequencies, because you don't get much, kind of like when you make a fist, and if you're on a surface area like a bed or a seat that might have a spring mechanism, a reclining mechanism in it, and you make a fist, and you shake, you can feel. I can feel my body shaking at the moment, and my vision is blurring because I'm shaking everything, and I could just see everything vibrating. Uh, Whew, yeah, and you think just that amount, and you think, woof. Do I get that sort of amount on a sub bass speaker or even the screen speakers? Oh yeah, I could get bass, but is it that same experience? No, because I don't have the bed in the bedroom, in the cinema room. I got a rocker seats, but they got spring kind of mechanism sort of thing, so they the bottom part is, and the top and the back seat, it flexes. Um, mm, you just got to have a room where, you can just put a slope in it. Um, what about the opposite? Well, the opposite would be so that you take the ceiling area and this is and then you make it so that the ceiling is going down at an angle, and so the front area would still be great. But the problem there is then if you got a second row and this mm, no, the room's got to be really great big. Otherwise, you're going to be, I think, be bumping your head on the ceiling. Um, yeah. That's generally the only way around it. Have I got a drink? Have I got a beverage over there? I think I brought myself a beverage in. Oh, yeah, I did. Yeah. And the wave that, is always going to be different. So you gradually go through the waves on observing the wave. Between the different frequencies, different low frequencies, the low wave of maybe start at 1 hertz. It's going to look like it's going flat, sort of thing, because the wavelength is incredibly long. And then you gradually go through the wave, 1 hertz, 2, 3, 4, 5, 6, 7, 8, and that wave just starts to change until you get up to a point where it starts to, it has this curve, and then you just keep on going and going and going until you get up to the high frequencies, and then that wave just gets narrower, narrower, and narrower and narrower until it's almost down to a few millimeters up on the very high frequencies that we won't really hear that much. They're there, but we just can't hear them. It's just like astronomy. You can observe it, you can see it, but you can't touch it. Though you may have it on an image thing, and you're only touching the screen, so it's hundreds of light years away. So for the better, I would say, because we're nothing more than a menacing species, and you don't know what that planet might be like. It might be very nice and green and lush and everything, very very great, nice oxygen levels, and it doesn't need us to come along meddle with it and mess it up, if you know what I mean. Anyway, yeah, so observing. It's the same with, I suppose, these integrators. They say this and that, they want to come around your home. You look at a typical home cinema room and all these things with, what do you call them, bass traps. I wonder if it is a bit of a trap of maybe a scam, snake oil, or maybe a trap of the amount of money you would spend on it. Then again, you look at it and you think, well, I could build that myself. I don't need, and I'd probably you'd be able to build it less, because when you buy something, they got to put something a little bit extra on it, labor and a little extra. So, they want to make a profit back naturally. But you just look at these materials and think, I could build that myself. But then, how much difference of a dB in frequency is it going to matter? If it's a small amount, then that's a bit disappointing. You want something great, you want to see like a significant figure that you can hear a difference, notice a difference. Not something that's going to be marginal, minor. That's like, I suppose that's like buying, I don't know. That's like some bullshit with like Mars bar, saying they're going to make their Mars bar just a little extra percentage larger for the same price. I mean, a Mars bar used to be about 25 pence. Well, that's back in the 1980s, but you look at the price of a Mars bar today, they do sometimes a smaller version of a Mars bar, and it's just got a ridiculous price on it. It's like sweeties are like drugs. They're legal, but yeah, yeah, really, you might as well shoplift it. The prices they're charging, daylight robbery today. Daylight. I think they should bring back the 25 pence Mars bar. It's doable. Yeah, you just want to get some significant result for the amount of for how much you spend and how much time you spent building it. You want to see significant result, not something just, oh gosh, that didn't seem to work. Yeah, back to the drawing board. And also looking at a cinema design between its ceiling and the rest of the roof, because it's just aesthetics. Just put in a room, and then there's you go a bit higher above it, and then you notice there's about maybe another 8-foot ceiling height or whatever until you go up, until it goes right up to the roof. What's the thickness of the material? How much of the bass frequency gets through that? What's it doing? Does it serve a purpose? Because otherwise it's just air ducting for the air conditioning. up there in electricals, usually. um, mm, yeah. Hmm. It's easy to do little tests with a little speaker, because it's still going to, depending on the base cone size and what sine waves you can get through it, and what can be observed on the RTA. And you build, say, something small, like a little test um, prototype laboratory sort of thing, something small, and you have something so that you can tilt the floor. So if you were to put a speaker, um, depending on how it's designed, into the box, maybe have the speakers flush mounted into the box, and then put some microphones in it, and then have something where you tilt the angle of the floor, and you tilt it, and then observe the frequency on the RTA. There should be a slight variance in change, but that's just a small box area. It depends on how big the box thing is. Maybe a 4-foot box or something, square or rectangular, and then just do some rough calculations, so that, oh yeah, if your floor was tilted slightly, so so you're gonna have maybe 2, maybe 3 rows. It depends on how high the ceiling is, I suppose. And how much dB less do you get at the back of the room at certain frequencies, so they don't boom. I suppose an alternative, is like maybe attaching materials to the ceiling, so it makes the ceiling at the back thick. So use very thick, dense materials, maybe lots of layers of plasterboard or MDF, and have it all screwed up so it goes into the ceiling joists. So it's very secure, so it ain't gonna fall down. And just make it very thick. That that should lower down some of the bass frequencies, rather than just equalizing it. Because if you equalize it, the result at the front is going to go down a bit. Not that you're going to notice, because you're not going to be at the front. The result may change just a little, maybe in the middle of the room. I'd have to observe it again. Maybe I'll take a few measurements with the microphones with A and B RTAs turned on. So I'd put one microphone on the floor near the door. I could set up 4 microphones. I could put one microphone so it's up near, close to the ceiling. Or maybe just orientate it and just put it on the boom and set it at a certain height, and then I can move it up close to the ceiling to see how how many dB level the frequency has gone up. Maybe also do a frequency sweep so I could see the the graphs overlay and see what the the differences are. Um, I mean, those numbers might look okay to someone else, oh yeah, it's got big peaks, oh yeah, or like that. But usually certain bass frequencies on our ears, sometimes it just doesn't seem natural. Um, and you're not probably getting a lot of actual vibration. So that cone, it's got some movement, some feel on it. If you put your hand fingers on the cone, you can feel the energy. But the rest of the motor structure of the vibration going out is from the back of the magnet structure is not coupled with the rest of the room. It's fitted inside a box that's just either laying on the floor or it's raised off the floor, and it's not really doing much. Um, whereas an engine on a bus, all that is coupled to the vehicle. That's why you feel the mechanical vibration. You hear it acoustically, and you feel the mechanical and it all seems natural, or man-made. It all seems, yeah, it's okay, so to speak. I suppose the same goes with a rocket, because the motor engines are below, and everything's all connected. It's not as if they got some special dampening in between just to well, maybe they do, to minimize some stresses going through the vehicle. Um, yeah, so it's a sort of problem thing solving. Anyway, I'm gonna get some sleep, and I'll probably do something maybe oh gosh, maybe later today, later in the later this late afternoon. Set up the microphones and see what I can see. Just trying to think. If you're up, you got an angle like that, and you got something to point downwards, so you can direct it and amplify it on, say, on the top of a mountain. So someone's down here at the bottom, maybe 1,000 feet or so. Because usually, if you yell out that way, you're going to get a little bit of the sound. It's going to go downwards, like, and most I would say it's going to go out that way, and that way. Even though that way is going to be pointless because there's no ceiling there, and it will just dissipate. Yes, yes, yes. So you're outside. You're outside. Certain things have got base energies and such on vehicles, and I could mention other things, but I don't feel I want to because it's very depressing. Um, but you think of vehicles and that. Um, they got to get a certain base energy. they're going to give a certain base energy, but it's not going to really boom that much because there's a great ceiling height, and there's nothing really to push that base energy back down this way. It depends on what sort of energy it is and how long it's lasting for. But yeah, if that say like was say that same vehicle was in say a garage, a tunnel, a car park or such, it might have a different sound because there's a ceiling above. It's going to have a different sound as well as an echoey sound. Typically in a garage, car park area, it's going to have a bit of an echoey sound compared to the outside where it's totally the opposite sound. You get total opposite sound frequency. Yeah, I suppose I might do something later. Maybe I'll grab one of my little small speakers, little JBL control ones, and move it around, sort of thing, and just observe frequency, sort of thing. That's of course providing, of course, I'm really up to it. I got to be have the right balance of blood circulation and such, and diabetes and everything. Oh, crikey, it's got to be balanced. Otherwise, I can't observe these things to satisfy my curiosity. Because if I could see these results and such, then then other rooms would also see a similar result. And then you just, we don't need it. We don't need these acoustic technician people coming around our home. It's just, they're just grabbing money, for Christ's sakes, just so they could be in your home or whatever. They don't really care. They just think that their premium prices for doing whatever it is they do is just is acceptable. But I think anyway, enough of those. Yeah, so I'll see later. See what I'll do later in the day. On 3, 1.